Hi there, my name is Srihith, and my project is AlgoViz. My course is the Princeton's algorithms on Coursera. So, one fun fact about me is that this summer I'm going to be visiting New York City. So, the course. I chose to take the Princeton's algorithms course because data structures and algorithms are very fundamental to computer science. Further, these skills are tested very heavily in interviews. So, in the course, I learned about data structures, algorithmic complexity in big O notation, such as the O to the n squared. And then I also learned about different types of sorting algorithms, such as selection sort or merge sort. And then also about searching algorithms like linear search and binary search. Then I learned about last in, first out, order for stacks, and first in, first out order for queues. Also learned of various different topics, such as hash tables or balanced search trees. So after I finished my course in a couple weeks, I focused on building my project. I chose to build an algorithm visualizer because existing visualizers that I used throughout the course in order to learn the concepts and algorithms had two major flaws. Either they had huge amounts of volume of data that sorted very quickly, which made it hard to understand what was happening. Other ones were way too basic or hard to use. So I wanted to make a visualizer that is very easy to use, but also helps students understand how algorithms work step by step rather than just learning by looking at it. And I also chose to do this for sorting and searching algorithms in order to practice the concept that I actually learned during the course. So this is my project. My project is AlgoViz, which is the algorithm visualizer. I built it as a static HTML page. So how it works is first you pick an algorithm that either sorting or searching, and then you can run the algorithm on a number of cases in order to watch and learn how it works. And then there's a couple of features that let you analyze the results and actually understand how the algorithm works intuitively as well as in code. So first, for the sorting algorithm. Sorting algorithm features various different algorithms that you could use. For example, bubble sort, selection sort, insert sort for time complexity of O to the n squared. Or you can also use faster algorithms such as merge sort, quick sort, which have a time complexity of O to the n log n. After that, the user can select the array size as well as the speed of how fast they want the algorithm to go. After that, they can select if they want it to be a random case, if they wanted it to be sorted, which is the best case, or reverse, which could be one of the worst cases, or evil, which is just like a fun feature added. So you can compare different algorithms on different cases in order to figure out which one's best for which. And then on the side here, we have the code in different languages, for example, Python, C++, and Java for each of the different algorithms. And then there's additional information about each algorithm on the right. So for example, if we run this, while at default, the element is colored in as blue, when it's comparing, it's highlighted in yellow. And then after it's finished, it's highlighted, all of the colors are changed to green. And then at the very top, there's a small description of what the algorithm actually is. So for example, for merge sort, it will recursively split the array in halves, then merges the sorted halves back together in order to finish a final sorted algorithm. And then while the array is actually getting sorted, in the code on the right box, we could see the code running. So this is pseudocode for the algorithm. So someone could look at how the algorithm's running and then look at the code and understand which line corresponds to which action being performed. And at the bottom, we could see that element 10 is being swapped with element 4. And then there's also back and forth step in order to figure out what is going on step to step. So if we were to decrease the array size and then randomize it, we could see step by step that it's checking to see if it's in order and swapping if it's not. So for bubble sort, this would mean that it's putting the larger value towards the end. So it checks two elements together, and then if one element is bigger, it would swap it so that the bigger element would go on the right. And it does it as many times until it finalizes and checks that the entire algorithm is sorted. Then after my sorting algorithms, I have my searching algorithms. So in my searching algorithms, I have two different algorithms, which is linear search and binary search, which are the most two prominent types of searching algorithms. So for linear search, it's obviously in time complexity of O to the n, while binary search is for time complexity of O to log n. So binary search will recursively repeat and half the array by half and compares the targets with the middle value. And it's really efficient, so it will always guarantee a best scenario. So if we were to run the algorithm, we could see here that when the element is unsearched, it's highlighted in blue, and when it's checking, it's highlighted in yellow, and when it's eliminated, the color changes to red. And then when the target value is found, it changes to green. And then similar to the sorting algorithm, we could see this on a step by step on how it works. And then same, the code is in Python, C++, and Java, which are the most used languages. And then you can see additional information here. So just like in the searching algorithms, we can also see how the code actually works while the algorithm is being run. So if we go to the next step, it goes into the while loop, and then it eliminates half of the array. And then we can see exactly how the code is working. So for tools, I primarily used GitHub Codespaces while coding my demo project. And then at the very end, I started using Claude Code. I tried using Gemini 3 and GPT-5 at the very start, but it was very buggy and I didn't like how the UI looked. So I switched over to using Claude models on Codespaces, and then finally for Claude Code for finishing touches. For my course overall, I used Gemini 3 in order to explain some of the more mathematical concepts, and GPT-5 to help me understand more abstract concepts, such as understanding how graph traversals work. So one challenge I faced was that every time I used a different model, I had to almost restart my entire project because different models didn't understand the code because it was in different formats, and they all tried doing a different thing. So that really mixed up my UI as one web page looked different than the other. So there wasn't really a coherent theme. So I had to restart in the middle and only use Claude in order to finish up my website and finalize it. One of the positives I liked was that I really liked the course because the instructor was very thorough in teaching the materials, and I also liked implementing the materials I learned in the course in my web development project through AlgoViz because I really wanted to develop a sorting algorithm, especially because I've seen a lot of these sorting algorithms on YouTube and while I was doing my course, but it was very hard to understand what it was actually doing. So it was like very nice trying to actually fix a problem that I see. My favorite piece of code was my Python code for merge sort. So for in my website, I wrote all the code for the different algorithms since I already wrote them for my course. So I wrote them all in Python and then used AI to help me assist in converting them to different languages such as C++ and Java. So this is my Python code that I wrote for merge sort. So in merge sort, the array, it would break the array into small parts and then sort these parts and then merge them back together in order to make larger parts and then combine these larger parts and finally in order to finally get a bigger fully sorted array. So by doing the dividing the big problem into smaller parts and sorting these smaller parts first, and then escalating to the bigger parts, it's able to sort these faster than simpler algorithms to check everything and have a time complexity of O to n squared. So instead of this, merge sort would have a time complexity of n log n, which is much faster. Thank you.